Welcome back. Let's look at differences in two variables now. And we'll look at those. We have a continuous response and categorical variable. Look at both hypothesis testing and confidence intervals. So take this as an example. We want to estimate the average difference in run times for men and women. And so here we have just thinking analyze distribution. We got two variables, time and gender. We could look at this in something like Graph Builder, and it shows us box plots and gives us a way of seeing time and then female and male. And we can see that it looks like they are different, but we'll look at it statistically. So the way we get to this is analyze fit y by x, which we've used before, and so that continuous variable would go in the y, categorical variable goes in the x, and then from the red triangle associated with that means and standard deviation. Okay, and it shows that process here, which then gives us the one-way ANOVA. And then from that one-way ANOVA, we have these results for upper and lower and upper confidence level. Now this is a test of differences, so we're saying on average this male minus female difference is minus 14.49. So you can see the average here is a value that's smaller than this, and so if we do the male minus female, right, then that average difference is going to be something negative. And we're saying the 95% confidence interval around this mean difference is in this interval of minus 20 to minus, say, 8.8, 8.9. Well, we can look at these two variables and differences using both confidence intervals and hypothesis testing, and we should reach the same conclusion whether we do each, but of course the confidence intervals we're given the values versus a conclusion on the test on the hypothesis test. So again, a two sample t-test, and the same platform that gives us the confidence intervals also gives us the p-values for the hypothesis testing. So that run difference that we were just looking at just a minute ago, the average difference of minus 14.49, okay, this gives us a different results, hypothesis testing results, p-values, depending on whether our test is a two-tailed test or a one-tail or a one-tail. So if we were looking at this one, our null would be that this difference, male minus female difference, is equal to 0. See, what we're really saying is that the average time for a male is equal to the same as the average time for a female. Okay, now if we just subtract, move the female to this side, we would see this difference here. So for the two-tailed test, that's our null, and for the two-tailed test, our alternate is that this is not equal to 0. Right, that there is some true difference between males and females in this running time. Small p-value, and so we would reject the null, accept the alternate, conclude yes, there is a difference in means in the running time between the male and female. If what we're trying to show was a one-tailed relationship, that either not just that there's a difference, but that this was either a positive or a negative difference, then we could use these one-tailed tests to evaluate that. That's it. See you next time.